G'day. Push notifications are a core feature for the mobile user's experience in using a mobile application. In this Oracle Mobile Cloud Service episode, we're going to investigate at a high level how push notifications work and how MCS makes push notifications easier for mobile developers. I'm Chris Muir from the Oracle Mobile Platform team. Thanks for joining me today. If you have a smartphone, then you already know what push notifications are. These are the messages you receive for apps, which you can of course read, then take actions on. How notifications are used really depends on the type of app. For an email app, it's a message that a new email has arrived. For an enterprise app, it might be something more sophisticated to say, well, maybe telling employees to check their bank accounts once the pay run is complete. Woohoo, we've been paid. Notifications have a lot of practical uses, so long as you don't overwhelm your users with too many notifications, which can be distracting at times. Oh, excuse me. Oh, it's a message from the local supermarket. There's a special on Vegemite. I'll be back in a moment. So as you can see, too many notifications can be distracting, and let's admit it, acting from Oracle employees can be distracting too. From a mobile developer's perspective, it's important to understand that each mobile vendor implements their own specific push notification solution in their respective mobile operating system that you must use for their respective platforms in turn. For example, for iOS, this is Apple's Push Notification Services, or APNS for short. And for Android, this is Google's Cloud Messaging Service, or GCM for short. While each vendor's push notification platform are implemented in different technologies, from a high-level view, their solutions are similar in that the mobile apps register for notifications with the vendor's push notification servers and a push server that you must build and deploy, and then at a later date, the app can receive push notification from those servers. Let's explain the registration process in a little bit more detail first. Okay, so before a mobile app can receive push notifications, the mobile app must first seek permission from the user to receive notifications. Now, on an iPhone or an iOS device, I should say, you'll get a little pop-up that says, do you want to receive notifications or not? And in turn, on Android, when you install the app, there's kind of a warning there when you're installing the app about what it's going to use in terms of permissions, which includes push notifications too. Assuming the user turns those services on, then the app itself must then register with the vendor's push notification system through the mobile operating system. In registering for push notifications, the following process is undertaken generically across Google's and Apple's solutions. First, the mobile app on the device registers with the remote push service provider relevant for their platform, such as APNS or GCM, supplying an app ID and a device ID. Note that the mobile application code doesn't call the vendor's push service directly. This is handled by an underlying mobile platform operating system call on behalf of the application when it wants to register. This is important to understand, as if the mobile app is undeployed from the mobile device, the operating system will take care of unregistering the device for push notifications for that specific mobile app. There's nothing a mobile developer needs to do in this case. Next, the push server provider in the same request returns a device token to the application on the mobile device. Third, the app then sends the token plus other identifying tokens such as a user ID to a custom-built push server, typically one you provide, commonly referred to as the push server, to keep track of the tokens and therefore indirectly the devices that have registered for push notifications. Finally, fourth, your custom push server will store these identifiers in a persistent store for later use when we want to send out the actual push notification messages. Now, after the registration process is complete, at some stage in the future, not straight away, but in the future, you'll want to send that mobile app and the user a push notification. Now, let's discuss that. This is initiated by you from your own push server with the following steps. First, your custom-built server will provide a mechanism, maybe a web console or a published web service, to raise a push notification. This would include information about the actual notification message, what app to raise the notification against, which users to send the message to, and so on. Then from the persistent store, we then fetch one or more of the device tokens we stored during the registration process on our push server that represent the actual mobile devices to send the push notifications to. In the third step, our push server will then call the remote vendor's push service to send the message to one or more devices based on the device tokens we just retrieved, and of course the message that we want to send as well. Finally, fourth, the remote push service implemented by the vendor, again Apple or Google, will then send the notification to each mobile device, which can be virtually instantaneous or delayed depending on the vendor's own workload. And at this point, note how, again, only the mobile platform vendor can actually send the push notifications to the devices. You cannot send them directly to the mobile devices themselves. You need to go through Apple's and Google's services, but MCS will do that on your behalf. Given an understanding of the generic registration and push notification mechanism, what specific benefits does MCS provide? Well, firstly, while the push services provided by each vendor are similar, that is Apple and Google, they are not necessarily the same, and you are required to set up and host your own push server infrastructure for each platform you wish to support. As a result, besides writing the mobile code to register and respond to push notifications, mobile developers also need to bear the expense of building, provisioning, and maintaining their own servers to store the registered device tokens and raise push notifications with the vendor. In context of Oracle's Mobile Cloud Service, MCS, it simplifies this, providing both a mobile client SDK to simplify the push notification registration mechanism for the mobile apps, and a custom-built push notification server with additional push notification services so you don't have to build and maintain this yourself. The added bonus is MCS supports both Apple's push notification services and Google's push notification services, APNS and GCM, and giving you one generic solution for all platforms. In turn, when sending push notifications, MCS provides a very flexible messaging system to send messages to a range of devices based on all sorts of criteria like a specific device ID or a collection of device IDs, a specific user or a collection of users, or devices that have a specific device operating system such as iOS or Android, or any combination of these criteria, but sent on a predefined schedule. For example, at 1 AM in the morning, the night before a store-wide sale to inform your customers of tomorrow's bargains. But you don't have to stay up at 1 AM, you can schedule this. Get it? That's why it's such a good feature. Right, so now we have some ideas about the benefits of MCS's push notification services. But let's take a little bit of a round trip here and talk about some limitations. When working with push notifications, there are some key limitations that you need to be aware of. Firstly, MCS push notifications are still subject to the SLAs, that is the service level agreements, of the third-party vendor push notification services. Neither Apple nor Google guarantee the delivery of push notification to a device, and it's a mistake to rely on this. As such, you should not rely on your push notifications getting through to your mobile users. They may never see the actual message. In turn, the third-party push notification server vendors may have limits and a cost associated with the number of push notifications you send. Again, you need to take this into account. And finally, the end user has the choice not to accept notifications in the first place in their mobile application. They can turn them off. In iOS, you turn them off on the general settings pages. So again, you can't guarantee that the user will ever receive any of your messages. Do keep this in mind. Great, so given the opportunity to understand MCS push notifications at the high level, we now encourage you to watch the following episodes where you will start to learn about how to set up your apps for push notifications and send messages via the MCS user interface. So this is at the low level. Thanks for joining us. Hope you enjoyed this episode. We'll catch you very soon.